In this movie, I'm going to get started at creating twin stick shooter controls, and you can find these files inside the course companion files in the Assets Scenes Twin Stick Shooter Controls folder. What we have in this scene here is an orthographic camera. Inside the hierarchy panel, if I select the main camera object here, you can see from the object inspector that the camera has been tagged as the main camera here, and the projection type has been set to orthographic. So we have this truly top-down 2D view of the scene. We have our gun turret here, and the first thing I want to focus on is the ability for this turret to turn to face the mouse cursor in the scene. So right now, if I press the play button on the toolbar and I move my mouse around, you can see that this turret doesn't move at all, and I want to take care of that. So I'm going to come down here to the project panel, and I'm going to right-click and choose Create, and then choose C# script from the context menu, and I will name this file cursor face because it's going to make an object face the cursor. That is, it's going to align the forward vector of the object to face in the direction of the mouse cursor in the scene. So I'm going to double click on cursor face to open that script file inside MonoDevelop here, and here we have the code editor. I'm going to hold down the control key on the keyboard and scroll the middle mouse wheel just to make the text a bit larger here so we can see it better. Now, of course, the first thing we need to do is, since this script file is going to be adjusting the rotation of the object to face the cursor, we need to get access to the transform component. To do that, I'm going to create a new private variable, so private transform, and I'm going to have this transform to represent the transform for this variable, this object. And of course, we need the awake function, and inside there, we're going to get a reference to the transform component with this transform equals get component transform, like so. So I'm going to press Ctrl S to save that code. And of course, the magic is going to happen inside the update function. So the very first thing that we're going to need to do is to find the mouse position within the game viewport and convert that into a world space position so that our object, the turret object, can face that direction. To do that, I'm going to need to create a completely new vector, which is going to represent the converted mouse position in the world. So I'm going to call this mouse position, well, I'll call this mouse pos world, and it's going to equal camera dot main dot. Now, by using camera dot and main, I always get access to the camera in the scene that is tagged as the main camera here. So we have in this case one camera and it's tagged as the main camera. So from here on, I will be working with that camera. And the camera object supports the function, which is screen point, and it converts, well, it has several here. We have screen point to ray, screen to viewport point, and screen to world point. I actually want to use screen to world point. That's going to convert a position on the screen into a position within the world, because the mouse coordinates, of course, they are measured in screen space. So I'm going to choose screen to world point here, and we have to plug in a new vector. Now notice that this is a vector 3 position as opposed to a vector 2 position, even though the mouse coordinates in screen space is 2D coordinates. I'm just going to pass the value of 0 for the Z component. So I'm going to choose new vector 3 here. And the first component is going to be the X coordinate of the mouse position. So that's going to be input dot mouse, and it's going to be mouse position dot X. And I will then input mouse position dot Y. So I'm going to have mouse position dot Y. And then I'll also have mouse position dot Z, or rather it's going to be 0 for Z here. So I'm going to use mouse position Y, and there's going to be a 0 for the Z position here. So I'm going to just move this code over here a little bit just to improve readability. So we have this new vector 3, and it's going to input the mouse X, the mouse Y, and then 0 for the Z field. This is going to take the mouse coordinate and convert it into a world space position. Now the next thing we want to do, of course, is generate a direction vector that's going to be the difference from that world space position to our position. This will give us a vector telling us the direction in which we should look. So I'm going to create a new vector here, which is going to be vector 3, and I will call that look direction. And that's going to equal our mouse position here minus our transform dot position. That's going to be where we are. And that will give us a vector between the two. And then finally, I can use this transform dot local rotation, and it's going to equal a quaternion dot look rotation. We've seen this function before, which constructs a quaternion in a particular direction. And in this case, it's going to be the look direction. And I'm going to use the normalized version of that vector. That ensures that all the distance or the length of the vector is removed so that the vector only represents direction. So I'm going to have the normalized version here. And we also need to put the up vector. And in this case, I'm going to specify vector 3 dot up here, like so. Now, the one thing that I do want to do, and the one thing that I am missing here just slightly, is the modification of this mouse world position. Here we take the position of the mouse cursor on the screen and convert it to a world space position. But of course, what about the Y component? How deep into the world do we get back on this position here? How far away from the camera is the converted position? Well, I want to make sure that the Y position is going to be modified to the position of our object, so that our object is always going to be looking in a straight line straight ahead. We're not going to be looking slightly up or slightly down. So I'm going to modify the mouse world position here. So I'm going to come down to this line and choose mouse world position, and I'm going to modify it just by simply using a new vector 3. I'm going to keep all the components the same except for the Y component. So I'm going to skip that one for the moment, and I will leave the Z component unchanged as well, but the Y component will simply equal this transform dot Y, so that we're always looking straight ahead. And then I'm going to press, actually it's not going to be this transform dot Y, beg your pardon, it's going to be this transform position dot Y. And then I'm going to press Ctrl S on the keyboard to save that code. So here we have the completed code for this turret. I'm now going to close this and return back to Unity here, and Unity goes ahead and compiles that code. The last thing, of course, I need to do is to drag and drop the cursor face object onto the spaceship itself. So I'm going to select that, and you can see here we have the cursor face attached to this object. And then when I press play on the toolbar, we now have the object that is turning constantly to face the position of the mouse cursor here. You can see in both the scene viewport and the game tab here that as I move my mouse around, this object is constantly turning to align that normal vector, that forward vector of the object, to the mouse cursor. That's splendid. That's the first part of twin stick shooter controls created. The next part is firing ammo.